Hello, my name is Abdallah Faris and my student ID is 2016-00306. A MobiServe operator wants to implement an IEEE 802.11ax6G wireless local area network infrastructure all over Bahrain. So, this video is recorded to demonstrate how to implement IEEE 802.11ax6G wireless local area network. The objectives of the project. Before implementing the infrastructure, some important points should be kept in mind to ensure that the network quality of service, such as the kind of diversified traffic, and its priority for indoor and outdoor propagation environments, as well as the access point transmission range. The project designs and simulates the implementation of IEEE 802.11ax wireless local area network technologies using different metrics by Omnet++. Network planning and designing. Let's talk about network planning first. There are 6 main factors we should keep in mind when we come to plan for a network. The first one is quality of services, and I will call it QoS as a shortcut in the video. QoS is a term that refers to the technology applied to control data traffic by the network, designed to decrease interference such as packet loss and latency. Where in our network plan and based on the requirements, we utilize QoS to give the priority for the voice and video packets by decreasing their packet loss. The second factor is delay. It is a measure of mobile communication channels' multipath profile. It is commonly defined as the time difference between the arrival of the earliest multipath component and the arrival of the latest multipath components. The third factor is data rate. Data rate are the theoretical speeds that may give by a wireless access point under ideal laboratory conditions, employing all available spatial streams at the greatest modulation rate feasible. The data rate of 802.11ax standard is reached 9607.8 MB per second. The fourth factor is bandwidth. The data rate of wireless communication determined by its channel bandwidth. The higher the channel bandwidth, that means the faster the connection. One of the fundamental aspects of the 802.11ax standard is the utilization of 160 MHz channel bandwidth. The fifth factor is capacity. The capacity in the house is the number of users that will be connected to the router, which is 10 users. So, a router will be provided in the apartment with an access point to extend the range and for gaming and streaming reasons. The last factor is cell coverage area. It is the area that will be covered by the Wi-Fi signals where the user's devices can still be connected while moving around, but within this area. In the 802.11ax standard, the indoor cell coverage area is 30 meters and the outdoor is 120 meters, without consider the path loss. With the path loss, the indoor cell coverage area is approximately 27 meters. Network designing. This is the design of the indoor apartment where the 802.11ax standard is implemented. In addition, the path loss formula has been utilized. Moreover, the second access point has been provided to extend the range and for gaming and streaming purposes. Network topology. Indoor network justification. In the indoor environment, it has been used 2 routers can go up to 30 meters coverage range for a residential sized 57 multiplied by 29 meters to gain the network coverage for all of it. To perform that, it has been implementing ASUS RT-AX89X AX6000 routers. The routers support 802.11ax technology, 2.4 and 5 GHz dual band frequency, The 2.4 GHz can perform 1148 MB per second, and the 5 GHz can go up to 4804 MB per second. These routers perform a data transfer rate up to 9607.8 MB per second, and there is 8 ports provided. The routers have 8 antennas that can perform the signal range very highly. In addition, the path loss equation has been implemented to calculate the path loss, where the path loss is 83.68 dB. Outdoor network justification. In the outdoor environment, it has utilized antenna, and the coverage range of each antenna is approximately 120 meters. So the distance between the antennas should be around 100 meters to ensure that a proper handover of the user's data and information will happen between the antennas. In addition, the population of a modern country is higher than in a rural country. As a result, more antennas should be provided in the modern country. Implementation. There are two important files utilized to implement the network in Omnet++, where they have been used to simulate 802.11ax indoor network. The first one is omnetpp.ini, and the second one is qosshowcase.ned. In the omnetpp.ini file, the simulation time set up for 10 seconds. Also, the server apps have been set up. In addition, the client apps have been set up too. Also, the message length for each app has been set up. And based on the requirements, we consider the services and set up the QoS class, which the services are background, best effort, video, and voice. Also, set up the classifier for packets. We set up the most priority services for the voice and video packets, and set up the source is the client and the destination is the server. In the NED file, 5 modules have been imported from iNet package, and 2 of them are nodes. The modules are IPv4 network configurator, wireless host, which is the first node, access point, which is the second node, IEEE 802.11 scalar radio medium, and integrated visualizer. After that, it will assign several parameters to these modules. Network evaluation. These photos are representing the QoS packet sent and received values of all applications after running the simulator. And we can see that the video and voice applications packets sent and received approximately same, which means the path loss is approximately 0. On the other hand, these photos are representing the non-QoS packets sent and received values of all applications after running the simulator. And we can see that there is a huge path loss in the packets received, where the packets received of the voice is 70 and the packets received of the video is 894. The charts show the throughput over the time of the QoS and non-QoS application services. The blue line represents the background information, the red line represents the best effort information, the green line represents the video information, and the yellow line represents the voice information. The y-axis will represent the throughput in MB per second, while the x-axis will represent the time in seconds. The non-QoS chart shows that the best effort is the highest throughput and the voice is the lowest throughput. On the other side, the QoS chart shows that the video is the highest throughput and the voice is the lowest throughput. Result and discussion. Path loss of the QoS and non-QoS both are represented in the bar chart, where it showed the packet loss ratio of each application service: background, best effort, video, and voice. And we can see that in the non-QoS bar chart, the highest ratio of path loss in the voice application service, and the second highest ratio of path loss is in the video application service. On the other side, the QoS bar chart, the highest ratio of path loss is in the background application service, and the second highest ratio of path loss is in the best effort application service, and the path loss of the voice and video application services are approximately zero. Conclusion and recommendations. In conclusion, the project focuses on wireless components and metrics such as channel access method, antennas, and network coverage. Moreover, the report gave a fully indoor design with justifying it and its gave implementation for non-QoS and QoS with calculating the path loss for indoor environment and the implementation of the path loss. Additionally, I will recommend several things to improve the network performance. First, Wi-Fi 7 should be developed with more data rate and bandwidth in the upcoming days. Second, more access points might be implemented to extend the area and to increase the number of users. Third, the outdoor environment should be planned and justified. Fourth, tri-band frequency band class could be provided in the router. Last, a limitation for the router users should be provided. Finally, thank you for listening to my presentation. I'll be more than glad to answer your questions if you have any.